Hello guys, today we'll talk about the set class. A set class uh, is, we're going towards the last steps towards our post-tonal, atonal music analysis. And in the set class lectures, we will talk about what it is and why do we need it. And then we're going to talk about the examples of trichordal set classes. Trichordal means three notes, any grouping of three notes. And then we'll talk about how to read the list of set class. You'll get the list later. And then how to analyze with the set classes. So among those four steps, four lectures, we will focus on the lecture one today. What it is and why do we need it. To start, let's talk about the diatonic tonal concepts. So what is a set class and why do we need it? And let's talk about this notes here. We have all these different sounding notes, right? We have F, A and C, C, A and F. Let me see if I can play that. So F, A and C sounds like this. C, A and F sounds like this. Right? We have E flat, C, and A flat. And we have E flat, A flat, and C. And we have G sharp, C sharp, and E sharp. Oh, G sharp, C sharp, and E sharp. Okay, all these notes, right? They all sound different, right? But at some level, we actually consider them as being part of the same group, right? So first two, they are part of the same F major group, right? These are two F majors, and the next two is part of A flat major, and then the last one is a C sharp major, right? So there's at the chord voicing, every chord sounds different, but and one step more further deeper down, we can consider them as two different voicing of the same chord, right? It is important to know what remains the same, right? So the same chord, F major, can have a two different voicing. Same chord, A flat, has a two different voicing. C sharp major has many, among many voicings, these are one of two, right? And if we go one step deeper, we can say that all of them are example of major triad, right? So when you say it's a major triad can be F major, A flat major, C sharp major, and each of the chords can be voiced differently like this, right? So there is a chord quality here. Does it make sense? So all of them are different, and each of this, if you think about this, the notations here, the voicings, actually is also an abstraction from the actual sound. So the C sharp major triad played by violin and piano or choir, they all sound different, but we somehow equate them and represent it in this voicing, right? And then this voicing, we can abstract it further down and call this a C major triad, C sharp major triad, and then we abstract even further down and call them a major triad. So there is at least three levels happening here, where towards the top it's more closer to actually sounding notes, and towards the bottom is more like abstracted groupings of things. Does it make sense? Okay, so if that's the case, when you can actually list the major triads or triad qualities. And there are major triad, minor triad, augmented triad, and diminished triad, right? These are the 4 triad types that we know and love, right? But triad actually can be more than this. This is only just 4 of the most heavily used, but there are way more triads. For example, triad like this, where it is a triad, yes, because it is 3 notes stacked in thirds, right? Whatever the third is stacked by thirds, so it is a triad. But we have no name for this type of quality because there is no way to call E triple sharp, G triple flat, B quadruple sharp as a quality, right? Because it doesn't happen as often. We don't have really a name for it. So in that way, there is a gap in our system of labeling, right? We only recognize the one that happens more commonly, but there are almost unlimited amount of triad qualities that is possible. We just don't talk about it. So to kind of fill the gap, we are expanding our notion of triad and call them a trichord. Trichord meaning any grouping of 3 notes. And you feel like there's unlimited number of things, but actually in terms of a trichord, there are only 12 distinct trichord. And let's see how that works. So let's go back in our different levels of voicings and the chords and see if we can map this onto the same thing. So if you look at these 3 notes, we have G, E, G, and A flat. So E, G, and A flat. We have C, B, and E flat. And we have E, G sharp, and F. All these are what they call a pitch set, right? Group of pitch, actually sounding, more closer to actually sounding notes, right? And octave is different. If you remember from the earlier lecture, pitch space is vertical space. It goes infinitely higher and infinitely lower. This F is different from this F, right? So there's an octave equivalent. And we actually close this vertical one-dimensional space, right? Because it's a line, and close the loop and make a circle so that the pitch class space is the circular space. So we disregard this octave and just write it as this: E, A flat, and G, B, E flat, and C, F, G sharp, and E. These are pitch class set, right? So there's a difference between them. The top one is more closer to the actually sounding. The bottom one is more abstracted. Okay, and we actually go one step further and arrange it so that they follow some certain order of intervals, right? The most compact way to pick to organize these 3 pitch classes, and that is the normal form, right? So pitch class set can be many different things, but normal form is a kind of a standardized version of various pitch class sets. Does it make sense? And after the normal form, and I put the normal form here in integer notation here, we can also look at this as, if you look at the interval structure, we have 3, 1, 1, 3, and 1, 3. That means if you do I transformation of this, if you do, let's say, what is this? I7. If you do T7I of this, then you will end up here. Where is it? If you do, they are related by T7I, right? And from here to here, they are related by T0I, right? So these two are relatable. Insert some kind of a transformation, either transposition or inversion, right? So we can actually standardize even further from here, which is which is how we end up here. And this is what they call the prime form. The prime form is the most standard way to organize any trichord, and it always starts from 0, and it's always most packed to the left. So instead, if you have a choice between 1 to 3 and 3 to 1, always pick the one that is most packed to the left. So 0, 1, 4. Yeah, so that is the prime form. And here's a little definition I made. Prime form is used as the representative of all of its transformations, including transposition and inversion. Right. So when you say, yeah, and then the pitch class set, yeah, let's look at this. 478, E03, 458, they all belong to set class 014. So the prime form can stand in for representing all the other pitch class that can turn into the prime form. Does it make sense? So when you say yeah, so that's what it is, I think. Yeah, the prime form is used as a representative of all of all of its transformations, and that works as a group set class. Set class 014 includes all these 478, E03, 458, and all of these pitch class sets, among many others. Okay, so for Monday, I want you to figure out the set class for these 8 pitch class sets. And I will do 2 for you, so you will need to do 6. We still have to enter the answer, but here's how to figure out the prime form. In order to figure out the prime form, first you need to find the normal form of the given pitch class set, and you transpose it so that the first pitch class is 0, and you make sure that the pitch class set is most packed to the left. So if you have, for example, a choice between 013 and 023, you pick the 013 because it is packed to the left because interval class 1 is here. Okay, so with that in mind, let's do number 1, TE14. So TE14. Let's first figure out whether this is a normal form or not. I feel like this is in normal form, but let's just make sure. 1, 2, and 3, right? Yeah, and then 4 to 10 is how far? It's 6. So we are leaving out the largest interval on the outside, so this is the most compact form. You can also look at it in the clock face. That looks like this. 10, 11, 1, and 4. So 10, 11, 1, 4, right? So this is the normal form. So what you need to do to figure out the prime form is you transpose it, and also this is most compact to the left, right? Most packed to the left. So basically what you need to do is you kind of recount it starting here as it's 0, and then you just add whatever the step that takes to the next one. So 0, 1, 2, 3, 4, 5, 6. So prime form for 10, 11, 1, 4 is 0, 1, 3, 6. In other words, pitch class set 10, 11, 1, 4 belongs to the set class 0, 1, 3, 6. Does it make sense? When you say set class, you also sometimes people use SC in front to make it a set class. Okay, so that is that. Let's do one more. Question number 5. We have what are these notes? We have A flat, C, E flat, G flat. So A flat dominant 7 plus what is this? B flat, D flat, and F. B flat minor triad, right? So let's list all the notes which are A flat. I'm gonna put it in the integer, so it'll be 8, 10, 0, 1, 3, 5, and 6, right? We have A flat, C, E flat, G flat, and B flat, D flat, F, right? So this is the note. And we need to figure out whether this is in normal form or not. How would you do that? We need to first plot it on the clockwise. And we have 0, 1, 3, 5, 6, 8, 10. Well, there's so many notes here. And we need to kind of look at it and see where the gaps are. And we need to turn it into the form where it's most packed to the left. And we need to always count in a clockwise manner. So we should either start from here and on, or we should start from here and on, right? Those are the two ways that will result in half step packed to the left side. Okay, let's take a look at those two options. We have one way to do it is 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 1. We don't know yet whether this is a prime form or not. And the other option is start from here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 3, 5, 7, 8, 10. Okay. And the answer is kind of clear now, because if you compare these two, you can see that this is all the other notes are the same, right? 0 and 1, 3, 5, they're all the same. And between 6 and 7 here, having 6 here will make it more compact to the left, right? Because interval between this is 1, and interval between these two is 2, right? So this becomes our prime form. So it belongs to the set class 0, 1, 3, 5, 6, 8, 10. Hope this helps, and I want you to finish the rest. Yes, and upload the answer on the Blackboard. Okay, I will see you Monday.